So we are recording the session. This is Webcast 3 for Algebra 1 for Associate Degree Programs in MRI and Ultrasound for Gurnik Academy. I am passing the microphone and the screen over to your instructor. Here we go. If you can make your screen available, turn on your screen, Karen.
I did.
Okay, excellent.
We have that lag. Is it showing over there yet? You seeing it?
Yet.
Should be there any minute.
Okay, here we go. All right, thank you very much. I'm muting myself out. It's all yours.
Thank you so much. Okay. So good morning, everybody. I really want to thank you guys for coming to these sessions. Appreciate that a lot. It shows a lot of good things that an instructor likes to see in their students. So, you know, welcome. I'm glad you guys could make it again. Okay, I have just an announcement myself. For your homeworks, what I'm going to wind up doing, y'all excuse me too, I have like a little cold this morning, allergies. What I'm going to wind up doing with your homework is I'm going to post a key, a solution key, and I'll explain more on the post. But I'm going to put what's going to go on in a general post, a general forum post for y'all. So if there's questions about your homework, you know, and how it's going to get done, graded, and how you'll see it, I'm going to explain more of that in a little while today. Actually, after this, I'm going to start putting that post up. So anyway, so you'll hear more about it. So thank y'all for being patient with that. And thank y'all for being patient with the links too. Like Ms. Jelena said, you know, we did inherit this course, and so a lot of times when an instructor inherits a course, there's some kinks to work through. So, but we're doing what we can, and you guys are great students. So thank y'all. Okay, so topic-wise, let's see. All right. I'm appreciating that. I want you guys to go ahead and put the problems you want to see. If you have requests, go ahead and put them in the questions box right now. And then as I'm done just kind of going over what you're going to be looking for this week, I'm going to go see what you guys have. Okay, definitely number 14 on page 83. Got a lot of questions about that one. We may even warm up with it. I'm going to check it out. So, okay, so if you have any questions on certain problems that you'd like to see, go ahead and put them in the questions box, okay, as we go along. If you think of something as we go ahead, okay. But let me go ahead and just talk to you guys about what's in store for this week, okay. Let's see. All right, there we go. So, this week, where's my little paper? This week you guys are looking at 2.5 through 2.8, if I'm not mistaken, okay? And so what you're going to be looking at this week is a lot of word problems. Some of them are going to be pretty simple. Some of them you've seen before. All of them, there's so many examples that you could find online, or you can find on the YouTube channel. That when I'm done with the general forum post, my goal today is I'm going to try to find another video example of each type. And so that should help you too, but I'm going to take my time and find a really good one of each type. But I have a couple of items, things I want to go over with y'all that I've seen like some issues with at the homeworks that I was able to look at so far. And this is like with solving of the equations, okay? And so, let me see. So, you know, okay, I got that, Brianna. I see your questions. Good, thank you. But I want to go over just a couple of good warm-up problems as far as solving equations. We kind of left off on that the other day. Again, you guys, sorry about what we call down here in Louisiana a croup. Sorry for my cough and my clearing my throat. So if there's a point where y'all can't hear me, let me know. Okay. So, okay. All right, here's my first equation for y'all. Here it comes. And I'm going to take this one straight out of this homework. Okay, let's see. Let me see what's that one. All right. I'm sorry, guys. I lost my page for a second. I got it. All right. Thank you. Okay. So we were talking last time about, and I'm just going to do this. We're talking about keeping the scales of equality balanced. So that's a huge thing, you know, for an equation. Let's see. All right. So here's an example, okay? Solving equations. Now, the thing that allows us to add and subtract the same thing to both sides, multiply, divide, or perform the same operation to both sides of an equal sign would be your properties of equality. And that was totally equation. Let me finish writing this before I talk. I'm so not good at writing and talking at the same time. It's sad, bad, terrible. Solving equations. Okay, so what allows us to do that would be the properties of equality. Okay, and so I'm going to keep that as a general statement right here, okay? So look, I'm doing that again. Equality. Okay, so if you're adding the same thing to both sides, it's an addition property of equality. Okay. Now you won't see a subtraction property of equality because subtraction is what? Adding a negative. So you're going to see just addition properties of equality. For multiplication properties of equality, we're multiplying or dividing both sides by the same amount. Okay. So here's this example. Okay. Let's see. We're going to start off. I'll start off pretty simple. Let's go here. Example, I'm going to put solve these equations. This is a good warm-up for us. I'm just going to write solve. Okay, negative 3x plus 4 is equal to 19. Okay, so what we want to do here is remember that this is the scale right here. This equal sign is the scale that we want to keep balanced. Okay, look, it keeps disappearing on me. It's wild. I think it thinks I'm scratching it out. Okay, so first we're going to start off with addition and subtraction. It's kind of like we're undoing an order of operations, almost, you know. So we want to isolate whatever contains a variable. If you see that this term has the variable x in it, we want that to be by itself first, okay? So it's like you're working towards isolating x on one side of the equal sign, okay? And so we're going to start off by picking off a little bit at a time, layers. So we're going to subtract 4 first. If we do that to the left, we must do that to the right. Okay? So it'll cancel here. And now you're left with just the negative 3x. Okay, 19 minus 4, 15. Okay, so now we have negative 3 times x. Okay, notice nothing's between the 3 and the x, so that's multiplication. The operation that undoes multiplication, in other words, the inverse operation, would be division. Okay, so if we divide both sides by this negative 3, both sides, don't forget your negative. Now typically, you guys got to be careful. Right here is where people get into trouble with their sign rules. So please be careful with that. Okay, of course these guys cancel out, these negatives, and the 3's do cancel into 1. So now it's just x, or understood to be a 1x, by the way, right? We don't write that typically. Okay, so x is equal to, we don't want to leave the negative in the denominator, do we? We want to put that at the top or in the front. Since this is going to be an integer answer, we'll just put it right here. 15 divided by 3 is 5. Okay, so here is our solution. I had a student ask me, how can I check the equations, or, you know, when I'm, mainly for equations is what the question was about, so let me go here. So the question was, how can I check the equations I solve? Okay, let me make some room here. Okay. So what you do when you find a solution, to check it, let me kind of make it a different color here. It's very good practice to check, because it gives you practice with other skills problems that you could run into for a test, or say a midterm, who knows. Anyway, if there are problems in the beginning of these algebra courses that say, you know, check or let us know or verify that this is a solution to this equation. Well, that's basically what we're doing here when we're checking. We're verifying here that -5 is actually a solution to the original equation. So what you'll do is you'll write the original equation, and where there's an x, open a set of parentheses. Okay? And now what I'm going to do is take the solution that I found, which is this -5, and I'm going to plug it in. And what I'm going to do is work on this side only, right? The right side of the equation is already done. Okay? So -3 times -5 is positive, right? Two negatives multiplied to a positive. So we'll have 15 plus 4 equal to 19. And so, yeah, 15 plus 4 is 19. You want to come down, bring everything down. Notice the format that I'm holding on to, that equal sign format. I'm not bringing one side down. It's not one-sided, because basically what you're looking for is you want to ask yourself if it's a true statement or a false statement. So what you're doing in the end when you're checking or verifying something is you're asking, is this true or false? Okay, let me close that. Okay, come back to me. Okay, true or false. And of course this is true. And okay, so this checks out, which means that -5 is a solution. So in other words, you got the problem right. So if you're asked to solve an equation, this is how you check. It doesn't matter. You can have more than one solution. You would go do this with each solution. Of course, I did it long-windedly because I'm teaching it to you, but it doesn't take long at all to check your work when you're solving. Okay, so let's try another one. I'm going to give you guys one that's got a little more meat to it. Okay, let me see. Here we are. Okay, this is page 80. Did we have one on page 80? I'm going to look at y'all's questions because there might be one I could do from y'all. Let's see. Anybody with one from page 80? Not yet. Okay, ready? Okay, alrighty. So nobody's got anything on 80, so I'm just going to go ahead and pick one. Alright, so we're going to solve this one. Okay, get my bearings. Alright, so we'll take, we're going to do number 10. Okay, and that'll give us a really good warm-up. This is number 10 on page 80 in your textbook. Okay, so -5x minus, open bracket, and no, if you haven't noticed, if you haven't figured this out, the bracket like this in place of, it's just kind of, it's like a large set of parentheses. When we've had to use parentheses already, we expand up to brackets. So they kind of serve the same purpose. Okay. Writing this down. Okay. Okay, so solve this equation. This is -5x minus, in brackets, 4 minus, in parentheses, 3 minus x, close parentheses, close bracket, equal to the opposite of 4x plus 6 in parentheses. Okay, so order of operations. So when you have something that's kind of a little more complex than the first problem I did, and you have to work on just the left or just the right, or in this case both. Remember your order of operations. So important. Okay, so refer back to that. So we need I need you guys to remember. You have to always use the order of operations. So I'm going to make that little note here. Refer back to the order of operations. Parentheses, exponents, multiply, divide, left to right, then add, subtract, left to right. Okay, so let's begin. Inside, we want to look in the innermost set of parentheses. So here's inside the innermost set of parentheses. 3 minus x, we don't know what x is, so we have to leave it like that. So what we do to get rid of these parentheses here is we're going to actually distribute this negative, okay? Now, if you'd like to, you can write a 1. And so it is like we're multiplying -1 times each item, each term inside the parentheses. So here's how that goes, okay? And we'll bring everything down that we have not worked with. That is so crucial, you guys, okay? You can leave this as a bracket, or you can downgrade it to parentheses. Once you distribute that -1, those parentheses will be gone. Okay, so now -1 times +3 minus 3. Now -1 times -x. So negative times a negative is going to be positive or plus, and then it'll just be x. Okay, so that's all I've done is I've taken the parentheses inside there, and I was able to eliminate them through distribution. So let's bring down the right side. I can go ahead and distribute on the right as well. Like I said, if you want to put a 1, if it's just a subtraction sign, you're welcome to. It's understood that that is -1, okay? Or you can think of it as taking the opposite of, and I can talk that out for you here. So taking the opposite of +4x, oh, let me put that back. Taking the opposite of +4x, excuse me, will be -4x, right? Taking the opposite of +6, right, becomes subtract 6, or plus a -6. We'll just put -6. Okay? So 2 different ways in this problem that you can think of subtraction, or when you distribute a negative. On the left side, you can either think of it as distributing a -1. On the right side, you can think of it as taking the opposite of each term in the parentheses. Okay? Now, the next step. Okay, so what we need to do now is combine like terms inside. So here we have this 4 and this -3 here. These guys can combine, and it'll make our problem a little more easy to deal with. Now I'm going to go ahead and downgrade the brackets to parentheses here. So 4 minus 3 is 1. Bring down the plus x. Okay, and just bring down that side. Again, I'm going to distribute another negative. This is really working your sign rules out, so watch your signs. Everybody, be careful. Please, you know, sometimes we start working quickly or whatever, and we all do it. I do it still. Sometimes I'll catch myself with a sign rule. One little thing will kind of confuse you a lot in the end, so be careful. So what? The opposite of 1 is -1. The opposite of plus x is going to be minus x. Bring down the right side. Notice I'm bringing everything down. Even though you think it might be time-consuming or taking up so much space, it's worth it. It keeps it organized. And notice I'm trying to keep my equality, my equal signs kind of lined up. You know, as I go along, keep them at least a little bit lined up. So you can kind of keep stuff sussed out on what's left side, what's right side. Now we have more like terms to combine. So let's take a look. Okay, my pen's not working. All right, so what do we have? We have this -5x. We have minus x. Okay, there we go, pen. So we want to combine these guys and this guy. I don't know, my pen is not working for some reason. Let me see if I can make it work. Uh-oh. Okay, let's see. I'm just going to have to do this. My handwriting's about to get a little more, little not so nice. Let's try. I think I can do this though. Okay, so now we'll have what? This is -5, and look, here we can write the 1. That's also understood to be in front of x. -5 and -1 will be -6. Let's see. X. You know, I didn't realize how much I really depend on my little pen. I have a tablet that I write with. It plugs in like a mouse, and it's so funny. So bring everything down you have not worked on. And look, while I struggle with writing, this is a perfect opportunity for you to try to work ahead and try to solve this, and then come back to see if you did it right as I go along. Okay. Actually, I'm going to unplug and replug my tablet. And let's see if it can start working again while you work ahead, okay? All right, yay, it's working. Okay. Wonderful. Yeah, that's better. Okay. All right, so now we're going to move x to one side and get our constant terms to the other side. Constant term, what's that, you say? Constant is a term that is constantly equal to the same number. Like for instance, look at the last one on the right. Look at this, a -6, okay? Let's take that. -6 is a constant. It does not have an x attached to it, in other words. This is a constant term. So you'll hear that a lot in textbooks or in lecture notes or whatever. You'll hear it called a constant or just a constant term. Okay? So a little side note. Okay. So now we're going to we'll do this. We'll put our variables on the left and our constant terms on the right. So let's go ahead and move the 4x to the left. It's -4x. So what will we do to both sides? We'll add it, right? So if it's subtraction or a negative, we'll add it. That'll cause it to eliminate on the right and pop up on the left. Now, what property is that? Can anybody guess? You can write it in the questions box if you'd like. Can anybody tell me that? What property is that allows us to add the inverse of a number? Oh, I just said it. Add a number's negative to it to make 0, to help it cancel out. You know, I don't know if anybody knows that. It's the additive inverse. Okay? All right? Additive inverse. That's when we add the opposite, or that's it. No, that's basically, and it will cancel out. Okay, so working ahead. Excuse me, y'all. So now we have this, -6x plus 4x. Now we're getting back on the road, guys. And now we're going to take this -1, and we would like to have its additive inverse to both sides, right? And it'll pop up on the right, cancel out on the left. So now if it's subtracted, we're going to add it to both sides, balanced, right? So, all right. Now, last step. We're almost done. So let's take a look. We have -2 multiplied times x. So we want to divide that off, okay? Take the negative with you, right? That's important. We want just x, not the opposite x. We want just positive x. Both sides, right? Cancels here, right? I'm going to show you guys another way of looking at this last step, and a way to verify it. Let me show you what's going on in this one. What allows me to divide by the number that's multiplied, or vice versa, on both sides. Okay, let's see. when you multiply a number, say -2, by its reciprocal. So what's the reciprocal of -2? It's the same sign, it's just the fraction is flipped. So the reciprocal of -2 is -1/2. So in a reciprocal, right, or the multiplicative inverse, we keep the sign when you're finding the reciprocal or the multiplicative inverse. That's the same thing. You know, you keep your sign, by the way, because the rule states that when I multiply it times its reciprocal, it needs to be 1, positive 1. Okay? So negative times a negative will be positive. And of course the 2's cancel and you get the 1. Okay? So that's what allows us to take care of this part. So it allows us to remove what's attached to x through multiplication. Okay? So I wanted to kind of point that out. I had a question about that, like how to explain that. Someone wanted that to be explained. Okay. Now, this is our solution, and I'm going to let you guys check it. Like, you guys can practice it. I think I need to move on to something else right now because I don't want to run out of time. Okay. I want to get to some of the word problems you guys are going to look at. All right. Actually, I want to get to some of y'all problems too. So let me take a look and see real quick if somebody's got something I can use for my next topic I wanted to go over. Where's my questions box? All right. All right. Let's see. Okay. That actually would be a good problem to do. All right. All right. So 83. I'm going to page 83 in your textbook. Oh, okay. Okay, and let's see. Hold on a sec. Okay. Before I look at number 14, I want to show you guys how to do the lower numbers in this group. If you go to page 83, yeah, it's 83. 83, if we look at the section that's labeled Guided Practice at the top of the page, it's like in exercises 7 through 14, solve your answer for the unknown variable. And this is all about what's the trick to eliminating a fraction from an equation. And I'm going to show you guys how we can do that with the least common multiple. I think this is the neatest trick because it really helps a really difficult looking fraction become quite tame. So it's helpful to know this skill. Okay, so what we're going to do is we're going to call this example C. Okay, I think we'll go ahead and let's take a look at let me see. We're going to look at number 8 first, okay? So go to 8. All right. So number 8. This is example C is number 8 on page 83. All right. So we're still solving, okay? Same directions we've been using, but we have fractions involved. We have what? 2/3 x minus 5/2 x. Let me put that x a little higher. All right. All right, and then 5/2. It's strange. I'm copying from one screen to another screen, so my eyes, it plays with your eyes a little bit. So thank y'all for being patient. Okay, now here we go. This is the deal. The first thing you want to look at, first thing you want to think whenever you see this equation or one like it is, don't panic. I know how to do this, right? Well, after we look at this now. What you're going to do is look at just those denominators, okay? Let's look at what's making it look unsavory to the untrained eye. You guys are going to have the trained eye now. We want to find the least common multiple of these denominators, or in other words, what would you use for your common denominator? If you were going to put everything over a common denominator, what would you use? Okay, so we're not going to put it, but we will not be putting everything over the common denominator. We're going to use the common denominator to eliminate the fractions, okay? We're going to actually make the problem a lot simpler. And I'm not even going to combine the like terms first, okay? So put a little note. You don't have to put a note, but I'm going to put a note. You guys could always come copy this later. The LCM, or my most efficient common denominator, of 2 and 3 is what? 6. So that is what I'm going to use to eliminate my fractions. Now here's the setup, okay? So let me box this guy in, get it separated from our problem. I'm going to take 6 and I'm going to multiply it into the left side and the right side of the equation. Okay, so I'm going to take a 6. Go ahead and use a bracket for now. And I'm going to multiply it times the left and the right. Get my pen. So let me go ahead and just write down. Now this is the step you'll probably be able to skip from here on out, but this is helping you understand what's going on. You'll have to practice this and really decide that for yourselves. So, okay, and then we have equal. Take a 6. Now if I multiply a 6 into the left side, I have to do it to the right side, correct? Do that. Okay, and so let me fill this in with my right side of my equation. Even that one even the one that's not a fraction form. Everything comes along. Okay, so here's what's going to happen. Let's go ahead and distribute our 6 into each term of the equation. So 6 goes here and here on this side, and then it'll get distributed into 3 different terms on the right side. So now we have what? We have, and this is important, what I'm about to say. Try to keep the 6 even with the numerator, since it is a numerator, right? You can even write it like that if you want to. But it will help you to cancel out in the next step, to clean this up. This can get a little messy. You want to skip lines, and you want to keep numerators higher, denominators lower. Okay? It's a super important thing to do, to stay very organized in this type of problem. Okay? Now 6, I'm going to keep it over 1 just to kind of help with that. And this part of the reason I'm using ruled paper whenever I do these on my computer with you guys, the ruled lines help a lot too. So now we're going to distribute it onto the right. Okay, here we go. Now it's going to go here, 6 times 22. And I'm just going to hold off on that multiplication for now. And now 6 times. Now watch, I'm going to put my subtraction first, then the 6 times the 2/3 x. Okay, so now I need to go back and perform the cancellations to see what happens. Okay, this is the whole point, is this next step. Okay, the step I just wrote would be probably what you would want to go ahead and write. So here we need to kind of check it out. We need to say, well, 3 goes into itself once, and into 6 how many times? While I'm highlighting this, go ahead and try to cancel. Go ahead of me for one step while I'm doing this. I'm showing you the places where we can cancel or reduce. Okay, try to get the next step. And of course, we can multiply the 6 times the 22. Put that in a different color. All right. All right, so here we go. Hopefully you went through it and tried it. And of course, if you're watching the video later, you can pause the video. 3 goes into itself once, into 6 twice. So now what do I have? I have 2 times 2, which leaves me with 4x. Okay, 2 goes into itself once and into 6 3 times, which leaves me with what? Bring your minus sign down, your subtraction. Then we have what? 3 times 5 is 15x. Don't forget that's an extra. We're going to combine those guys after we're finished with this step. Remember, as tempting as it can be, one step at a time. Keep your eyes on the prize for this step. 2 goes into itself once. 2 goes into 6 3 times. Now 3 times 5, 15x. Okay, of course, 6 times 22 is what? Okay, if you want to do this by hand, you can kind of do that. And we'll have plus 2, and carry the 1, 6 times 2, 132. Okay. All right, and finally, 3 goes into itself once, into 6 twice. And now we have what? 2 times 2. Bring that subtraction down to 4x. All right, now on this step, what we're going to do is combine like terms, right? Now we can combine the terms that end with x to the first power. Okay, in other words, we have what? We have these guys. You can add the coefficients of these, and then there's these. You can add the coefficients on these terms. So go ahead of me for a second. I'm going to like count to 10 or something, or you can pause the video if it's later on. And I think I just erased some of my x. There you go. Go ahead and try to take this one step, but don't panic. I want you guys to just take it one step, and then we're going to move on together. So combine those like terms and see what you get. Okay? And all right. That's probably enough time there. Okay. So what's happening here? We have on the left side, we have positive 4 minus 15. So what? Minus 11x. All right, come on. Oh, there goes. Every time. Now we have 15x minus 4x, which is what? 15 minus 4 is 11. All right, come on now. I think it wants me to put a bullet, but no. Plus 132. Okay. Now what we need to do is get all our variables to the left, all the constants to the right. And you can make all your variables go to the right and all your constants to the left. That's up to you. It doesn't matter which side, but you want your variable terms on one side, the constants on the other. Because remember, we need to have something that looks like x equal to some number, if possible. Okay, so now I'm going to move that positive 11x that's on the right side. I want to move that to the left. Okay, so we're wanting to get this guy. Let's see, that one. We want to move this guy to the left. Okay, so we'll subtract. If it's added here, see it's positive, we're going to subtract it from both sides. And it pops up here on the left. Okay. Let me close that out. Okay, so it will cancel here, and we'll have what? Negative 22x is equal to 132. And so now what? Now I have 22 multiplied times x, negative 22 multiplied times x, excuse me. Let me give myself some room. Push that down. There you go. And so I need to, if it's multiplied, I'm going to divide it off. We spoke about that earlier. And you could put this, divide by negative 22, divide by negative 22. Okay, so it'll cancel here. It becomes 1x, or just x. And then we have a negative answer, right? Our sign will be negative. And 132 divided by 22 is what? 6. Okay. All right. So here's your solution. You can check it. We'll do a quick check since that's something we spoke about. go to the original problem. We want to check it with the original problem, and I'll do that in red here quickly. I'm just going to write out the check. 2/3. Oh, excuse me. Open the parentheses where I have an X. And I'm going to come back and put my solution in afterwards. Okay. All right. So we want to come back and plug in the -6. Okay. So -6. Now you can go ahead and what should happen though is you'll be able to cancel quite simply, just like we did in that second, third step in the previous problem. I mean, in the problem we just did. So in other words, 3 goes in itself once into -6, -2 times, right? So 2 times -2 would be -4. 2 goes in itself once into -6, -3 times. So now -5 times -3 is going to be +15. 2 negatives make a positive when we multiply. Okay, watch your signs. This is another little sketchy little area where your sign rule can really get in a shambles if you're not careful. 2 goes into itself once. 2 goes into -6, -3, right? So 5 times -3, -15. Of course, we have the +22 we want to bring down. Now, 3 goes into -6. Don't forget that negative. That should be 2. Now, -2 times -2, +4. Okay? And look, if you catch me making a mistake, please raise your hand. I'm begging you. I'm human. It happens. We can all make a mistake here and there. Okay? So, yeah. It's okay. It's fine with me. Okay, so 15 minus 4 is 11. Come here, and we'll have 22 plus 4. Let's see, -15. 22 plus 4, 26. So let me go ahead and do that very quick, just to be. I'm not trusting my math brain. How about? And that is 11. Okay, come on, ink pen. So true or false? True. So we did find the correct solution. So x equal to -6 is a correct solution. Okay? Alrighty. Now, what I want to look at is one of the types of word problems that you're going to be dealing with this week. Okay, and I'm going to start off with a consecutive integer. I'm going to try to hurry though. Let me see. Let me get my book up. All right, there it is. All right, let me go back. I tell you what, before I get into that though, I'm going to go ahead and look at your questions while I have you guys live, because I could go and make a video and post it of that too. So let me see. Let me look at your questions. Questions. Oh, there it goes. Okay. Textbook page 83. Okay. Oh, I forgot about that one. Okay, we could look at 14. Actually, can you, number 14, let me attack that with you individually, Michelle. And it's very similar to the problem we just did. So I'm hoping you maybe could try it now. Just give it a try. And then get in touch with me if you still need help with that one. I'd be happy to do that. Okay, let's see. Question 19 from homework 3. Let's take a look. See. All right, so homework 3, question 19. All right, here we are. All right, I have that right here. So let's look at that one real quickly. Again, question 19 from homework 3. Okay. Okay. Oh, that's kind of like what you have to do. All right. Let's see. I don't want to run out of time either. Hold on. Oh, you got it now. Okay, awesome. Okay, so let's see. All right, so you got that one. Guided questions. Okay. Alrighty, so there's a couple of them on here that I would love to look at. I wish we had more time, you guys, but I'm going to fit what I can in here. Let me kind of get this out of the way. All right. My bearings. All right. Okay, so now, let's see, homework 3 is due today. Can I even do that today? Because I think you have, it's due. I might have to do a similar one, okay? Sorry. Let's see. All right. Okay, you guys, wait. I'll see you. Sorry, you guys. I'm trying to, did I get number 1? Okay. Okay, Jennifer. All right, Jennifer, I'm not sure which set of homework are you talking about? Which week? Is it from week 3 or 4? Let me know. Okay, thank you. Okay. Okay. I think what I'm going to do is I'm going to have to come back with you guys independently for that because I don't want to run out of time. Some of these could run out of time, okay? So what I'm going to do, plus I think I'm not seeing the printout quite right. My printout is not complete. So let me do this problem that I wanted to do. This is going to be something to help you guys with this coming up, the stuff you have to turn in next time. But it's something that will also help you with some of these word problems, the skills involved. And Jennifer and Brianna, I'm coming back to you guys, okay? So be patient with me. You need to see this too, so we'll do those in examples on our own. I'll put a video up or something. I'll talk to you guys after. But and I will too, so get ready. So look, here's an example, okay? This is something that consecutive integers. This gets people all the time, and there's a couple of reasons why. When we first look at word problems, I find a lot of students are kind of apprehensive to set up the information. Okay, this is this type of problem, consecutive integers. All right, and so what I'm going to do is a couple of these. Let me get these back up. Oh, malfunctions. Malfunctioning. I don't like malfunctioning equipment. Okay, here we go. All right, so we have that one, and then, all right, so 2 consecutive integers, and so let's make an A. We're going to find the integers, 2 consecutive integers. Have a sum of 31. Find the integers. Okay, so find these integers. Integers, okay. All right, so what you need to do when you have this type of worded problem, okay, there's going to be 2 types of examples here that I'm going to do for you. 2 consecutive integers. We're going to let, okay, this is what you begin with every time you do these, and most word problems, okay? So I guess you can call this the beginning of the solution. So we're going to let, and we'll use n for number, n equal the first integer. And if they're consecutive, what does that mean? That's one right after the other. So in other words, the next consecutive integer would be this one plus 1. So then we'll say n plus 1 would be the second integer. Simple as that. Okay? And you can even put in a little set of parentheses to kind of remind yourself that this is a number. The n plus 1 is one of the numbers I'm looking for. Okay? We need this little let statement in the beginning of these word problems and most other word problems too. We need these because what happens is the word number starts with n, I get that, but we're not using a variable that's really telling us everything about the stuff I'm looking for, what's the problem's asking me for. So we need a let statement like this for when we go back to answer the question, we know what we're going to plug right into. And it makes things quicker, simpler, and organized for you. So now let's set up this equation, okay? All right, so what do they have? They have a sum, right? So make sure you remember that. What does this mean? Right, a sum means they have addition, okay? And they have a sum of 31, or their sum is 31. Is the equal sign. And so 31 is going to be by itself on one side of the equal sign. Okay, so we need to add those two items, okay? So here's my equation. If I add n plus 1, and look, I'll put the parentheses on it for now. If I add these two numbers, I should get a 31. So there's the setup of your equation based on how we defined our integers that we're looking for. Okay, so that's really super important for you guys to kind of, this format right here where you set them up, you have your let statement, and then you have your equation. You do need to practice how you go about this and keep these parts very organized. Okay. Okay, so now, FYI, we don't need these parentheses, right, on the n plus 1, not technically, not to solve this equation. So, and let me try to make this snappy. We have n plus n is what? 2n, right? You can really just get rid of this here, get rid of the parentheses. Uh-oh. All right. Let me put it back now. I got you. Okay, so ink pen, come on, don't fail me now. All right, plus 1 is 31. Let me quickly get on with this because I'm running out of time. And I will get back to those other problems with y'all if you want to hang out for a minute or stay near your computer, and let's be in touch right after this, and we can talk about a plan to go over those right away or as soon as we can. So now solve this, and I have n is equal to 15. Here's the important part, okay? We have the first integer, right? So we have this one. What we need to do is answer the whole problem saying find both of these. So we need to come back and get n plus 1. So just under where you have n is equal to 15, we need to write n plus 1 is equal to 15 plus 1, or 16. So you can't forget you have these other problems. Now, really quickly, consecutive integers, typical representative or let statements, okay? If I'm asking for, let's say I have a problem, let's see, representing consecutive numbers, okay? Integers. Let's make this really snappy. Okay, I'm running out of time. This is super important. Let me hurry up and finish this idea here. Okay, representing consecutive numbers, how we would do that if I have consecutive even numbers or odds, they're the same. Okay, we're going to use, at this level, consecutive even or odd. Let's say I have 2 or 3. Okay, the first one, we're going to always let the first number be in or even x. That's fine. It doesn't matter. Okay, this is your first even or odd. Let's pick even. Okay, say it's 2. Then the next even number would be 4, right, or 2 up, so that n plus 2 would be the second even or odd. Then you go 2 from that one. So what you're going to do is add 2 to the last number. So, of course, 2 plus 2 is 4, right? So onto this, we're adding 2, n plus 6. Now look, this would be 1, 2, 3, 4 consecutive even or odd integers. But if they're asking for 2 or 3, you just want to pick those, the first 2 or the first 3. At any rate, this is for that. And then, of course, your plain consecutive integers would be n plus 1, n plus 2, n plus 3, just like we did in the example there. So, okay, you guys, let me see what I have a question to answer here. Number 10, I think. Yes, I'm going to do a video on those problems. I'm going to print out the ones you guys are asking me about right now, what I didn't get to have time for, and I'm going to come back and actually right now I'm going to record a video for y'all and post it on the YouTube channel in just a bit this afternoon, so you guys will see that. Okay, Jeffrey? So I'm not going to, I need to probably do that anyway because those problems take a while. Alrighty, so does anybody have any questions about anything we did today in this presentation? Oh, no problem, Jeffrey. I hear you. You are very welcome. No problem. I understand completely. I'm coming back to you. Hang in there. Got it, Jennifer? All right, Jennifer, I'm coming back with those problems too, so cool. I'm glad that helped you a lot. All righty. You guys, y'all have a great day. Be on the lookout for those homework things too. The homework key is going to be, it'll have solutions and the answers. It's not just a solution key. I mean, excuse me, it's not just an answer key. It's a solution key. So it'll help you guys to be able to check your work, okay? So, and you'll see your scores going up very soon too. So let me get these videos up, and that's what's on my agenda for the day. So I guess I got more work cut out for me. And you guys do too, so keep up the good work. Keep working hard. It pays off. Got to practice the math skills. Have a great day, y'all.